Okay, difference quotient. The different quotient is f of x plus h minus f of x all over h. So then the question ends up being, what is this? Well, f of x plus h is a y value at x plus h, and f of x is a y value at x. So if I draw a picture, this is some x value, this would be some y value. If I add h to the x value, that takes me to x plus h. This would be the y value. You can connect it with a line. So now we have two coordinate points. We have x, f of x, and x plus h, f of x plus h. Now the relationship is that if I take a look what this is right here, it's the long value, which is x plus h, subtract x. It's just the number we added, which is h. If I take this side right here and I look at the same idea, this is the long value, subtract the short value. So that if now third pen here, lost it. Now let's take a look at this relationship. We say the difference quotient of f of x plus h minus f of x all over h. Well, this is what we know as rise. This is what we know as run. This is the infamous rise over run, or what we know as the slope of the line. So all the difference quotient is the slope of the line so f of x plus h minus f of x over h is y2 minus y1, x2 minus x1 in function notation. So in function format. Now I like to approach this and you don't have to do it the way I do it, in what I call the 4-step process. I have to break it into 4 pieces. I look at the difference quotient I first calculate out f of x plus h. So that's step 1. I then calculate out f of x. That's step 2. Then I do the complete numerator. That's step 3. And then I do the whole thing. That's step 4. So I look at it as step 1, calculate out f of x plus h. Step 2, f of x. Step 3, f of x plus h minus f of x. Step 4 is then put it all over h. So that essentially what this guy is step 1, subtract what I got in step 2, and then what this is what I got in step 3 divided by h. So I kind of do that in pieces so that I don't get confused along the way, but the choice is yours.